Good afternoon, everyone. Am I audible to you?
Yes, sir.
Audible to you?
Yes, sir.
Yes, sir.
Yes, thank you. So, without wasting much time in discussion of the syllabus, now we will start our first chapter because the contents are huge contents are given in this subject, and we require some, as I discussed in earlier lecture also, we require some prerequisite to understand the microcontroller. So we are starting with chapter number 1 straight away. Subject name is mentioned here, microcontroller and its applications. But now the name has been changed a little bit. They used to call this subject as per new syllabus as a microcontroller applications, but the meaning is same. Chapter 1 is introduction to microcontroller. And now in this chapter we are discussing about the first module or first bit of that module, that is a block diagram of microprocessor. On this topic, there will be a question of 5 marks. Either a generic block diagram of microprocessor, otherwise it may be like a generic block diagram of microcontroller, or they may ask a question of difference between microprocessor and microcontroller. So this topic will carry almost 5 marks. Now I have to link this which discussion we have done in the last lecture. We were discussing what is meant by microprocessor based system. So that we have to put in terms of the generic block diagram. We said that a microprocessor is a chip, that is IC, and that IC will perform the mathematical operations like addition, subtraction, multiplication, division, logical operations like logically OR and XOR, inversion of data is done. That device is called as a microprocessor. Point number one. Secondly, whichever is the computation process like mathematical operation or logical operations or even instruction, everything should be mentioned in terms of logical levels. So I will have to explain everything in terms of logical level, which is high or low, yes or no, 1 or 0. So data may be represented in terms of 1010 format. Instruction must be represented in terms of 1010 format. Result which I am going to obtain should be represented in terms of 1010 format. Alphanumeric characters, A, B, C, D, special characters, hash, at the rate, everything for every symbol I require to represent in terms of 1010 format. Means I want to convert it in terms of binary language which will represent in terms of 1010. We know a set of 4 bit is called as nibble. A set of 8 bit is called as byte. A set of 16 bits is called as word. Further, the length will be increased with double word, quad word, and so on and so forth. So everything should be represented in terms of binary format. Okay, that is the point which we have discussed earlier also. Second most point is that a microprocessor has to communicate with the input device, it has to communicate with the output device, it has to communicate with the memory device. It has to communicate to the input device to accept the data 10, 20, 30, 40 and likewise. It has to communicate with the memory to accept the instructions addition, subtraction, multiplication, division and so on. It has to communicate with the output device like a monitor, printer to display the content. So, based on that discussion, I will be drawing a diagram which is known as a generic block diagram of microprocessor. And then eventually we will convert that to microcontroller. So, first of all, let me draw it. So, this is an IC called as microcontroller or sorry, microprocessor. My mistake. I am not discussing about controller, I am discussing about processor. The processor which perform the function like mathematical or logical functions in a microseconds. That is called as microprocessor. Now, why it microseconds? Because time microsecond is given is based on the frequency, and the frequency is in terms of megahertz. So 1 upon f is called time. So 1 upon mega means micro. So that is called as microprocessor. Okay. Yes, will you please join the class well before time? Yes. Yes, Narote, will you please join the class before time, scheduled time? I hope I'm audible to you. Narote, can you able to hear me?
Yes, sir.
That's good. Great. So, this is an IC called as microprocessor. It has to communicate with input devices. Let me draw it by block. So, this is a block to represent input devices like switches, keyboards, matrix keyboard, hexadecimal keyboard, and different keyboards are there. Joystick is a one more input device. It requires to communicate with the output device. Let me draw it by one more block. Output like a printer, plotter, display, monitor used to call, or even LEDs, LCDs likewise. To display the result, it requires to communicate with the memory. Draw it by a block known as memory. Memory, because in memory already we have stored the instructions. A set of instruction is called as program. Entire program is there. We write in terms of instruction 1, 2, 3, 4. That is called as program. Basically, what we say, it's a set of instruction. Instruction like addition, subtraction, multiplication, or an instruction. So it requires to communicate with the memory. Now, it has to communicate with this peripheral. This is called as peripheral devices. Peripheral devices like memory, input and output. So how to communicate? I mean, it has to process the data. Data is like 10 plus 20, answer will be 30. And for this process, we need to write a program. So for execution of that program, it requires to communicate with the memory input output. But before I move ahead, let me give you an example. The way we communicate with in a society, the way we communicate with a person residing at one location. Similarly, it has to communicate with the peripheral devices. So let me give you an idea. So just to explain this concept, what we will do. Now this is suppose a colony. This is suppose a colony. It consists of number of houses like 1, 2, 3, 4, second row. Similarly, now this colony is having number of houses, and suppose I am running a courier office and I have to deliver one package to that particular house. So my courier office is somewhere here, and I want to send one fellow to that house just to deliver that package or package, we can say package to that place. So what basically it requires? Now this fellow who is going to transfer that package to any of the house. I mean, for example, this is the second house. Row number 1, house number 2. Here, that fellow has to deliver that package. So what he requires? So this fellow requires the address, or he requires a path. This is a road. Yes, a road is defined. You have to walk on the road, or you have to drive a bike, or you have to drive a car and reach to the house. So this fellow must have the first thing, that is address of that house. So first thing is that this fellow must be having the address. Secondly, he will go to that address, but then what he will deliver? Yes, of course, he has to deliver a package to that house. So he must carry the package with him while walking on the road, while traveling on that road. So he must have that package, or we call this as a data or a box. So along with him, he will carry that box and he will reach to that house. Think the address is known to you, the package is with you, the boy will travel to that house, he will reach to the house. But normally the houses are closed, no? No, I mean, like if you are residing in an apartment, definitely the front door of that flat will be closed. Similarly, so means what, he has accessed that particular location, but could not able to access that house because the house is disabled because the door is locked. So what he will do, obviously, he will just ring the bell, push the bell button, the bell will ring. The moment bell will ring, somebody from the house will open the door. The moment that person opens the door, means what, the house becomes accessible to this courier boy. Means what, here itself you have to ring the bell. So please try to understand what is the minimum requirement for the courier boy to deliver the package to the particular house. The first thing is that the fellow must have the address with him. Secondly, he must have that data or a package to be delivered to the house. And third most thing is that he has to ring the bell. The moment he rings the bell, the house becomes accessible, house becomes enabled, and then he will be able to deliver that package to that person residing inside the house. Requirement. First requirement is address. In our colony, every house in a residential area, everywhere, every house has unique address. The address of that house should not be transferable or is not transferable to other house. That is very well known to us. Region-wise, we may be residing in a similar region or colony. Colony will be same, having number of, road, internal roads or building name, floor number, house number, flat number. So every address of the house will be unique. So depends upon number of locations, the address must be defined, and that address should not be transferable. The address of first house is not the second house address and not further. So unique address must be defined and depends upon number of houses in a colony. Unique addresses must be given to each and every one. Similar to that, when the processor has to communicate with memory input-output device, but a memory is not a single location. Your laptop may be having memory of 1 terabyte, or some small gadgets may be having a memory of some gigabytes. Kilo, mega, giga, tera, in that way, 10 to 3, 10 to 6, 10 to 9, 10 to 12, in that way the memory will increase. Means what? It has number of locations. So even though I shown it by block, no, practically it consists of number of registers. Every register is called as memory, 1, 2, 3, 4. Likewise, it has number of memory locations. And every location must have a unique address. Suppose the address of this is 0, address of next will be 1, address of next will be 2, likewise, n number of addresses will be given, depends upon the size. Similarly, the processor will not be able to communicate with only single input device. No, it can communicate with multiple input devices. 10 number of keyboards, 10 number of output devices, 10 number of displays. So even though I shown it by a single block, practically we can able to communicate multiple input devices, multiple output devices, and every device must have a unique address. Let me show it by this. What I want to show here, I want to show that a memory consists of number of locations. Every location, it may be empty or may be filled. Address should be changed, should be different. The houses who are residing in who are residing in a house that I don't know, maybe three people, four, five, six, I don't know the members in the house. Perhaps the address must be unique. In that house, the house may be empty or filled with the people. That I don't know. So whatever contents are present in the memory, right now I don't have to bother about it. Of course, I'm bothering about the address of every location. Okay, am I audible to you?
Yes, sir.
Yes, sir.
So, same for input, same for output. The way we have done here, we find the path to reach the location. Similarly, to find the location to which we want to communicate, to find a single input device to which at that time a processor wants to communicate, or to find a single output device at that time the processor wants to communicate, should be identified. And for that, we require a bus, a bunch, or road. A bunch is nothing but number of lines. Like this is one wire, second wire, third wire, fourth. Number of lines are joined, and that becomes a bunch. That is called as the path or address bus. So this is joining the address bus. So these number of lines, I mean, one, two, three, four, multiple lines are there. Depends upon the specification of the controller. Some of the lines are joined to memory, some lines are joined to input devices, and some lines are joined to output devices. Because this is a place who has to identify the location to which we want to communicate at that time. Second point is what? This has a one limitation. I mean, it's a very strong device. Go for, I mean, when we go for automation, perhaps it can communicate with only one location at one time. When this communicates with one of the memory location, it will not be able to communicate with input device, not be able to communicate with output device. Similarly, when this wants to find out which keyboard I want to communicate to accept the data for my process, only one location can be communicated. That time, it will not communicate with memory, not communicate with output device. So one communication, one identification, one address at one time. Of course, but the speed is very high. The frequency is in megahertz, as I said. The speed is in microseconds. So we can shift from communication to memory to I/O devices very easily, and we can able to understand it. Even we also, we can perform one task at one time, but our brain is running very fast, so we can't able to understand. But at the same time, we can do both activities. I'm speaking at the same time of writing, but definitely every process is done with some intermediate time slot. But the processor is very fast, so at the same time I can speak, I can see you, I can write over here. You may feel that, but it's not two things. One task at one time. So we have done. We will go in detail. So I think first task is over. Address is over. Now this fellow must carry a data with him. Otherwise, he will go to that address and he will ring the bell. But what to deliver? Because he haven't brought that data with him. That should not happen. So this has to carry a package with him and travel, walk on the road and reach to that particular house. data must be there. Similarly, address bus will define the address to which we want to communicate. But we require again a bunch of line. 1, 2, 3, 4 wires. Simple wires are there. These are wires, and these wires are to be used to transfer the data from processor to peripheral device or peripheral device to processor. I require a separate bunch of line. Of course, saying a separate bunch of line is not that true because same line address buses are demultiplexed. So at one time they will go for address and one time they will carry a data. But right now at this point of time we can say we require a bunch of line called as a bus to carry a data from this place to peripheral device back to the processor. Let me show you. So we require one more bunch of line consists of 1, 2, 3, 4, many lines are there. How many lines are there? Let me see afterwards. Now, with respect to memory, what we can do now? We can accept the instruction. So data will flow from this and will come to processor. A type of result will go from processor. We can store it in a memory. So for memory, we have both way communication. We draw it like this. Arrow, which is in a both way communication. Data can flow from processor to memory or memory back to processor. Does it happen with the input device? Input device means what? A data sent by device, input device will go to processor. Processor will not send a data to keyboard. Never know. From keyboard, we enter the number. That number will go to our computer. But from computer or laptop, we will not send a data to keyboard. So it's only a one-way direction. So data will flow towards the processor. Output device, a data can be on the display. The monitor will not send a data back to the PC. Similarly, we want to display. Display means data will be here. We can display it at output. Reverse path is not possible. So here we can show it by this. But if I want to discuss about this particular bus, this is a both-way communication. So I can say here, this is a bidirectional bus. It works in both directions. Data from one place to peripheral device back to processor. But this is not. This is only one way. Address code सांगतं, his fellow office will tell the address. Houses will not tell the address. Come to my house. No. This office must have address where we want to communicate. Similarly, this address bus must be of one direction. So this is called as address bus and this is called as data bus. थोडक्यात ऍड्रेस बसचं काम काय आहे? आपण मेमरी मधल्या कुठल्या लोकेशनची त्या मोमेंटला आपल्याला बोलायचं आहे ते सांगणार. सांगणं म्हणण्यापेक्षा to identify the location to which the microprocessor wants to communicate. Unique address सांगणं हे काम आहे याचे. आणि डेटाचं काम काय आहे? To carry a data from peripheral device to processor to peripheral device. So it is bidirectional. So I think two tasks are over now. So this is also done. ठीक है. This fellow got the address. He has carried that package along with him, reached to the house, but could not able to deliver that package to the person residing inside the house because the doors are closed. So that fellow has to ring the bell. The moment he rings the bell, somebody will open the door. Door will open means what? The house became accessible to this person, courier boy. Similarly, this address bus defines the address. Yes, it is one of the address from memory that is done. Data has been sent from this processor and it is going to place, it is going to store in a memory, but not possible because even though we got the address, even though we have that data with us to be stored in a memory, the location, this location is not enabled. So to enable it, to make it activated, hardware wise everything is fine, hardware wise everything is present, but it is not accessible. It is not enabled. To enable that place, we require one more bus. The bus is called as control bus. So this is one more bus. Let me draw it here. This is the control bus. Control bus will send, let me write over here. Control bus. त्याचं काम काय आहे? The address which is defined, identified by address, the data is reached to that house, no problem, that location, but the place must be enabled. Enable means what? Either we can send a data to memory, the read time data from memory, from input we can retrieve it and likewise. So let me show you by the signal. This is one signal and this is one more signal for memory. Why? I will tell you. This is the one signal to be given to input. So that input keyboard will be enabled. आपण नाही का जेव्हा पीसी ऑन करतो तेव्हा कीबोर्डला एक लाईट असतो ना का एलईडी लाईट that will glow just to indicate that yes keyboard is activated. Similarly, someone should be, some line is required to make it activated. This is single line, and for this it is second line. So I try to show the bus structure of processor. Same is for controller because when we differentiate a processor and controller, you understand the same structure is there. Memory, input devices, peripheral device, and output devices. So what you understand from this concept? Anyhow, in the first lecture, end of first lecture, we conclude that the microprocessor requires to communicate with memory, input, output devices. But then for communication, it requires three buses. The first bus means what? A bunch of line. First of all, it requires the address bus. Secondly, it requires a data bus. And thirdly, it requires a control bus. What is the function of address bus? Address bus is used to identify the location to which it wants to communicate at that point of time. Secondly, data bus. Data bus is a bunch of line which will carry a data from processor or controller to peripheral device back to the processor or controller. And a control bus is like a ringing a bell of a house just to make the place enable, activate for either storing a data or retrieving the data. It may be from memory, it may be from input device, it may be from output device. That depends upon the applications. Basically, it requires three buses. I'm going to explain every bus in detail now. Will you please tell me, have you got this concept up till now?
Yes, sir.
Yes, sir.
Yes, Shiva.
Yes, sir.
Others,
Yes, sir.
please. Thank you. Let us discuss about one by one buses and slowly as we go ahead, you will elaborate. Once I elaborate, you will understand. Before I move towards the next content, teaching to this subject is like a tree. Like tree I. In the first lecture, I will tell you everything. This is processor and this is controller. Everything I'll tell you, not in detail. Next lecture, I will explore some of the points. Same, controller and processor, maybe. And you will get some more knowledge. In third lecture, fourth lecture, in a successive lecture, I will just go on exploring or explaining the same contents in more detail. And then you will be able to understand the entire controller and be able to write the program. Somebody will say, why it should not be like point wise? It is not point wise because we require to deal with all the aspects of microcontroller at one time. It is not like if you are working in a chapter number 2, we require the help of those contents which are placed in a chapter number 5 and 6 also. So even though syllabus is given chapter wise, but teaching is little bit different. But don't get confused. I'll just teach the contents point wise. One, just like this is the first point, generic block diagram, 5 marks. Then the second. But normally the way of explaining it is like a building a tree. Okay, now we'll discuss about the address bus. Okay. Okay, now we start with the first point that is known to us. Address bus is used to identify the location from memory, to identify the input device, or to identify the output device one location at one time. So I write this is to identify the location from memory, input or output devices to which we want to communicate at that point of time. So this is the first point. It is called as a bus. Bus means what? It's a bunch of line. Number of lines, wires are there. So this is consists of number of wires. Those are called as address lines. The address line is what? Let me show you by this. Okay. So, sorry, this is the address line. This is line number 1, line number 2, line number 3, and it becomes a bunch. Now, number of lines that depends upon the size of memory and input devices and output devices. How many locations I want to identify, that will decide the number of lines. So basically, first line is called as A0. So this will be given as A0. And then A1, A2, A3, A4, A5, A6. Likewise, the last line will be N minus 1. And this is called as address bus. Okay, so the first line is A0, A1, A2, A3, A4, A5, A6, and this becomes an address bus. याचं नाव काय आहे लाईनचं A0. One more is A1, A2. The names are given. But then, how to decide how many address lines must be there in an address bus? That depends upon the location. बघूया कसं काय ते. आता एक लाईन आहे. आता जर काही लाईन 0 असेल तर 0 is the address given to one location. Line becomes 1, address given to second location. So with the help of single line, I can define only two addresses. एक address आहे 0, दूसरा आहे 1. Fine. Now we have two lines. Addresses. पहला address 0 0, दूसरा address 0 1, तीसरा address 1 0, चौथा address 1 1. So 0 0, 0 1, 1 0, 1 1. Apart from these four addresses, next address is not possible by two lines. If we have three lines, in that case, the first address will be 0 0 0. Next address will be 0 0 1. Next address will be 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. These are the possible combinations made by three lines. Count. The addresses will be 8. That is quite simple. one line, two addresses, two lines, four addresses, three lines, eight addresses. How many addresses can be generated by four lines? And then will you please tell me how many addresses will be generated by four line? एक line आहे दोन address शून्य किंवा एक दोन दोन line आहेत address will be 00011011 above that not possible four addresses तीन line आहेत 123 we will have eight addresses on a similar line. Somebody please tell me, maybe I'm wrong, I don't know. If we have four lines, how many different addresses can be generated by a controller?
16.
Yes,
16.
16. So that depends upon a formula. Let's see. So,
It may be 15, na?
kai.
For 3 lines, there should be 8 address lines, na?
Eight.
Then for 4, it should be 15, n minus 1.
16. 1 6.
Okay.
So the locations means what? Some of them from memory, some of them from input, some of them from output. Number of locations is equal to 2 raised to n is equal to 2 raised to n. It is what? It is called as number of address lines. Fine? Baga, address lines are given as A0 to AN minus 1. Total lines should be equal to n number of lines. N number of lines means what? We will fill up over here. Baga, 2 raised to 1, locations 2. 2 raised to 2, locations, 4. 2 raised to 3, locations 8. 2 raised to 4, locations 16. If the processor is having 16 number of lines, 16, 1 6, n should be equal to 1 6. 2 raised to 16 should be equal to 65,536 locations. On a similar line, you can find out the address lines which are in your laptop. For your laptop, the location is terabyte, 1 terabyte. Like this, 2, 4, 8, 16. There is not 1,000, there are terabyte locations. How many address lines are required? Those many address lines are present in your laptop. Of course, the lines are demultiplexed with some other hardware, but practically, ideally, you can say those much lines must be present in that device. कळतं काय म्हणतात रे?
Yes, sir.
आता काय बघायचं किती आहे इट डिपेंड्स ऑन variant 85 86 or different controllers and processors have a different address bus size but practically out of this entire take of like 1 2 3 4 lines the first line A0 to A7 first 8 lines 0 1 2 3 4 5 6 7 8 lines are called as lower order address bus. त्याचं नाव आहे लोअर ऑर्डर ॲड्रेस बस. पुढे A8 पासून A15 किती आहे 8 number of lines 8 number of lines is called as higher order address bus. आणि जर का नंबर ऑफ लाईन जास्त असतील तर ऑब्विसली A9 पासून
Your screen is
आता एन किती आहे मला पण माहिती प्रत्येक प्रोसेससाठी एन इज डिफरंट सो लास्ट लाइन लास्ट bunch is called as upper order address bus so this is called as upper order address bus. Okay, this is the formula. Number of locations is equal to 2 raised to n. I hope you might have taken this. If not taken, I suggest please note it down every time because we don't have separate time for writing. Meanwhile,
Sir,
up
your
till this
screen
point,
is blurred.
down to the last.
Continuously. Your screen is blurred continuously.
काय रे?
Screen blur दिसते sir.
I lost my connection. Wait.
So from last 2 minutes.
Wait. Okay. Mani sir. Yeah. हा बोल काय म्हणतोयस? Yeah, someone is asking me a question. Please go ahead. So point number one is over. Point number two is over. Am I audible to you?
Yes, sir.
Yes, sir.
Yes, sir.
Can you repeat this last one? Because can you repeat last one?
Last one. The entire number of lines, I don't know, it may be 4, 8, 16, or 21, 24, 28. We have to group them. The first group of 8 lines is called as lower order address bus. Second group of 8 lines is called as higher order address bus. The remaining group of number of lines is called as upper order address bus. And this combined is called as address bus, address lines, called as address bus.
Yes, sir. Okay.
So we have just seen two things to identify the location from this one location at one time. Address buses are defined in this way. Maximum locations are depends upon 2 raised to n. N is number of lines are given by n. Fine. So just these points we have seen. We have to add some more points in there. Okay, will you please tell me this bus is bidirectional or one directional? Because a processor is a device. Because the processor or a device which has to identify which memory location I want to communicate at this point of time, or which input device I want to communicate at this time, or output device. So the addresses are given only by controller, processor and controller to the peripheral devices. So the bus will not be a bidirectional, it should be one directional. So this is a unidirectional bus. This will offer the addresses, but then memory will not send the address. It will identify input device, it will identify the output device, but those devices will not identify processor because processor is only one, not multiple processors. So address bus should be a unique or one directional bus. Okay. So these are some of the points which we have discussed here. Okay, let me complete this and then we'll stop. I hope I'm audible and visible also.
Yes, sir.
Yes sir.
डेटा बस. डेटा बसचं काम काय आहे बरं? पहिलं का गोष्ट आहे की it has to carry a data from processor to peripheral device to processor. So that line is to transfer the data. Data म्हणजे काय? 1010 content. Data from processor to peripheral and vice versa. quite easy. But then what is bus? Of course, the bus is got a bunch of line. This is one line. This is second line. Maybe third line. Okay. So number of lines. Of course, that number of lines will depend upon the variant. Maybe having 8 number of lines is called as one bus. 16 number of lines. 32 bit. Your laptop is having a 64-bit processor. So at one time, 64 bits can be processed. Of course, my laptop is quite old. That is a 32-bit processor. So means what? That much number of bits can be handled in that string at one time. Recently, we are operating with the 64-bit processors. Likewise. So this is used to transfer the data from processor to peripheral device or a reverse wise. Of course, it consists of number of lines. Those are called as data lines. Data lines. First line is called as D0, D1, D2, D3, D4, D5, D6. Last line is called as Dm minus 1. So this is an entire data bus. A zone is number of lines are there. यातल्या पहिल्या 8 lines, first 8 lines are called as lower order data bus. So from D0 to D7 हा जो number of lines चा bunch आहे त्याला म्हणतो आपण lower order data bus. दिसते का रे? त्यानंतर जर का बस हा जास्त असेल, it consists of more number of lines. So next bunch 7 नंतर 8 ना 8 to D15 हा 8 लाईनचा बंच आहे त्याला म्हणतो आपण लोअर ऑर्डर डेटा बस. हा 8 लाईनचा बंच आहे त्याला म्हणतो आपण हायर ऑर्डर डेटा बस. Higher order data bus. Of course, but for our controller and processor, upper order address data bus is not used. So, of course, if number of lines are more than 16 to carry a data from processor to peripheral, peripheral to processor, that time we will call this as a upper order data bus. Right now, this is fine. One last point should be mentioned here. Let me ask you. The address bus is a unique or one directional. Will you please tell me, data bus is a one directional bus or bidirectional bus?
Bidirectional.
Bidirectional, because data can flow from processor to peripheral, peripheral to processor. So please add the last line. The last line is data bus is a bidirectional data bus. And in the next lecture, we will continue with the control bus. We differentiate what is called as processor, what is called as controller. Microprocessor, microcontroller. Just wait, let me take the attendance. Okay, yes. So, shall we stop here?
Yes, sir.
काही शंका असेल कोणाला तर प्लीज विचारा आताच. ठीक आहे. Otherwise, you can leave the class.